Welcome all to today's lecture. As we already know that in previous lectures I have been covering Unit 1 from Microprocessor and Microcontroller subject, which is being taught in 5th semester. So we have already covered the basics of 8085, its architecture, its pin diagram, and today I am going to cover 8085 instruction formats and addressing modes. So, what are the basics of instruction formats and addressing modes? As you all know that these information fields of instructions are very important. Which one? These. These are known as elements of instruction and it covers operation code, source and destination operand, source operand address, destination operand address, and next instruction address. So let's understand these terms one by one. First of all, the operation code. The operation code field in the instruction specifies the operation to be performed. The operation is specified by binary code, as we know that these machines understands only the machine language and which is the binary language. Hence, the name operation code or simply we can say opcode. So, the most commonly used term is opcode here. Next, source and destination operand. So, the source and destination operand field directly specifies the source or the destination operand particular to the instruction. So, in the instruction format of 8085, suppose we are having instruction move A, B. So, what will this instruction do? It will copy the contents of register B to the register A. So, here B register contents act as the source operand and the A register contents acts as the destination operand. Again, source operand address. In some instructions, the operand is specified as the address of the content. That is, like many a times instruction format specifies the address of the source operand rather than the contents. Similarly, the destination operand address, many a times instruction specifies the destination address. So, for example, the destination operand address for instruction INR M. So, M here denotes that this instruction will increase the contents stored in the memory by 1. So, and what is the memory? Memory is specified by the contents of HL register pair. So, this is how the addressing is done. And another thing is next instruction operand. So, the next instruction address tells the 8085 from where to fetch the next instruction after completion of execution of current instruction. For example, for branch instructions, the address of next instruction is to be fetched immediately. It is specified within the instruction. So, similarly in the jump instruction, suppose the instruction is jump 2000H, which it specifies the next instruction address as 2000H. So, these were the basic terms. Now, let's study these instruction formats. So, instruction formats basically specifies that in what form the instructions are specified, instructions are written, whether they are 1 byte, 2 byte. So, what are their forms? So, there are basically 3 forms in 8085. First is 1 byte instruction. So, its format is as opcode simply and it is of 8 bits. 1 byte means 8 bits opcode. For example, move A, B. This is an example of 1 byte instruction and its opcode is 78H. We already know that the machine always understands the opcode, that is understands the machine language, that is the binary language. So, 78, it can be written as yes, and 8 is So basically this is the code. So this code is equivalent to move A comma B. So this instruction and the data format of 8085 copies the contents of register B in register A. So these type of instructions are the examples of format 1, that is 1 byte instruction. Another format is 2 bytes instruction. So suppose, so in this format, first is the opcode and the second is the operand. So it consists of 2 bytes, that is 16 bits. For example, MVI B, 02H. So this is the example of format 2, that is the 2 byte instruction. What this instruction performs? It move this immediate data to B, that is the register B will hold 02H. So MVI B means that the immediate data is copied to the register B. The opcode for this instruction is 06H and is always followed by the byte data, that is the 02H in this case. So this is the data and MVI B is equivalent to 06H. So in this way 06 and then 02, then these 2 bytes are covered. So this instruction is a 2 byte instruction which copies immediate data into B register. In this way, this whole instruction is represented in the form of 2 bytes in machine language. Third format in 8085 is 3 byte instruction, that is as shown here, opcode, first operand and then second operand. So let's see. Understand this through the example. Suppose there is jump 6200H. So the opcode for this instruction is C3H and is always followed by 16-bit address. So in this case, the address is 6200H. So in this way, the complete format becomes C3 6200H. So in this way, 3 bytes are covered. Yes. So this instruction is a 3 byte instruction which leads to 16-bit address into program counter. So we can see that we went through the 3 instruction formats: 1 byte instruction, 2 byte instructions and 3 byte instructions. So whatever instructions of 8085 we come across, they can be categorized into any of the 3 instruction formats which I just told you. Okay. So any of the instruction of 8085 is covered by under any of the 3 formats. So in this, further going into details, that the opcode is unique for each instruction and data format of 8085 and contains the information about operation, register to be used, memory to be used. So as we know that when we study an instruction of 8085, so it will consist of a register, it may consist of an operand, it may consist of the address. So when it is consisting of any register, so there should be some code related to all the registers. So that code is specific. So what are the code? We have to understand this. If register B, C, D, E, H and L, and if there is the memory or the accumulator, so these codes are used. If we are talking about the register pairs, BC means 00, DE means 01, HL means 10, AF, that is the accumulator and flag register, and stack pointer, then 11. So in this way the codes are formed. Again, suppose MVI R, data. So MVI R means that we are moving some data into the register mentioned. So the code is the opcode. Yes. So I am talking about the first byte. The opcode is 00DDD. D means the destination register. So whatever register is here, the code is equivalent to this DDD, 3 bits. And what will this 3 DDD cover? it will depend upon this register used here, R. So you can relate this to the table. Similarly, LXI register pair comma data, that is a load the immediate data into the register pair. This is what this instruction is performing. So this register pair, and again 00 D, that is the destination register pair, 0001. This is the opcode, and this is tentative and depends upon the register pair we are using. So if B is LXI B comma data is this, so then 00 will be here. If LXI D is there, then 01 will be here. So in this way you can relate the data. Again move RD comma RS, that is 01 DDD SSS, that is the destination register and the source register. So destination register and these 3 bits and these 3 bits depends upon the registers used, and you can refer this table for the following data. So the operand is another name for data. It may appear in different forms: addresses, numbers, logic, characters, as I have already discussed. So the addresses means 16-bit address. Numbers means the 8085 supports the following numeric types. What are those? Signed integer, unsigned integers, and characters. So these 3 can be summed up as the another name for operands. So 8085 addressing modes. So addressing modes basically means that how you are addressing your operands. So the way of specifying the data in the instructions is termed as the addressing mode. The different ways that a microprocessor can access data are referred to as the addressing mode. So in 8085 there are 5 addressing modes: immediate addressing mode, register addressing mode, direct addressing mode, indirect addressing mode, and implied addressing mode. So we will go through these addressing modes one by one. So when we are talking about the immediate addressing mode, means the data is specified in the instruction itself immediately. So it can be 8-bit data also or the 16-bit data. How you will identify this addressing mode is that the instruction will be having the I letter as a suffix, like MVI A and LXI. So in this way. So let's go through the examples. MVI A comma 20H means that the 20H, this is the data which is being copied to the accumulator. Yes, similarly MVI M comma 30H means this 30H data will be copied to the memory. And what is the memory? Memory is the memory location pointed to by the contents of the HL register pair. Similarly, LXI stack pointer comma 2700H means this immediate data, 16-bit data will be moved, will be copied to the stack pointer. So since stack pointer is a 16-bit register, so 16-bit data is the immediate data here. Similarly, LDIH comma 10FFH. So 16-bit data is again copied to DE register pair. So these are the examples of the immediate addressing mode. Next, register addressing mode. So the operands are specified in the instruction in the form of registers. So the name of the registers are mentioned in the instructions. Let's understand this through examples. Move A comma B. In this case, both operands are registers. And what is this instruction doing? That it is copying the contents of register B into the register A. Again, SPHL, that is, it moves the contents of the HL register pair into the stack pointer. So these types of addressing modes are specifying these are having the operands as the registers. Add C means it adds the contents of the register C into the contents of accumulator, and the result is stored in accumulator itself. So since these instructions are having the registers, name of the registers as the operands. So these are categorized under register addressing mode. Next, direct addressing mode. So these instructions specifies the 16-bit address of the operand within the instruction itself. The second and the third bytes of instruction contains this 16-bit address. So like load LDA 2000H. What is this instruction performing? It is loading the accumulator with the data which is pointed to by which is stored at this memory location. So this is not the immediate data, this is the location, and at this location the data is stored and that data will be loaded into the accumulator. Similarly, SHLD, it stores the HL register pair into the two consecutive memory locations. So store from the HL register pair directly, means the HL register pair is the it's the contents of the L register is stored in the memory location 3000, and the higher order, that is the contents of H register is stored into the memory location 3001H. So in this way, the operands which are specified in the instructions are the addresses. Next is the indirect addressing mode in 8085, that is the memory address where the operand are located is specified by the contents of the register pair. Yes. So let's have a look and understand these through the examples. Like first example is move A, M. So it will move the contents of the memory location pointed by the HL register pair to the accumulator. That is wherever the M is, the term capital M is specified in the instruction, it means that we are talking about the data which is stored at the memory location which is being pointed to by the contents of HL register pair. So this is what we have to understand while using the term M. So it will move the contents of the memory location pointed by the HL register pair to the accumulator. So the address of the operands is indirectly specified in the instruction. Similarly, LDAXB, that is a load the accumulator with the register pair PC register to the accumulator. Now again LXIH, load immediate the HL pair with the address of the location 9570. So in this way, now next is the implied addressing mode in 8085. So in implied addressing mode, the operand is hidden and the data to be operated is available in the instruction itself. So these type of instructions does not contain the operand or any register name or any address, but the what is to be performed and which are the operands is already understood through the instruction only. For example, CMA. So it will complement the accumulator. CMA means it will complement the accumulator, or we can say it finds and stores the one complement of the contents of accumulator in A. Again RRC, that is the rotate the accumulator A right by 1 bit, and RLC, it rotate the accumulator A left by 1 bit. So in these instructions, no need to specify any operand. So it is not, we are not mentioning any operand, but we know that automatically the operand here used is accumulator. So these instructions are performed, these operations are performed on the accumulator itself. So these types of addressing modes is known as implied addressing modes, that the operands are already implied, they are already understood. So this completes our 5 addressing modes and the 3 instruction formats. So let's quickly revise the addressing modes again. So basically addressing modes means that how we are mentioning the operands in the instruction, mentioning the data in the instructions. So the and these are 5 in number in 8085. So first is the immediate addressing mode, then register addressing mode, direct addressing mode, indirect addressing mode, and implied addressing mode. As the name is suggesting, the immediate addressing mode means that the immediate data is mentioned in the instruction itself. Register addressing mode means that the name of the register is mentioned in the instruction. Direct addressing mode means the value of the address, that the memory address is mentioned in the instruction. Indirect addressing mode, that the instruction itself, the address is mentioned but it is indirectly mentioned. Implied addressing mode means the operands are already implied, they are understood. No need to mention any operands in the instructions. So in this way, today we complete the 2 topics of 8085, and these are instruction formats and addressing modes. So in further lectures, we will move on to the instruction set of 8085. Thank you. That's all for the day.